Good afternoon, everybody. How are we doing? Afternoon, evening, night, either way. I hope everyone's ready to learn some physics here. So what we're going to do is we're going to go through springs, simple harmonic motion, how it is affected by zero gravity or zero friction. Then we'll add a little bit of friction. We will adjust our spring constant, as we can see in our stiffness here. And before I'd mention friction, that will be our damping. Then once we get going, we'll play around a little bit. We'll add different weights. We'll see how that affects the velocity, height, periods of our springs. And along those same lines, we will change our spring constant. We will adjust the friction, and then we will be able to see how simple harmonic motion looks on a graph. So we've got height over here, we have velocity over here, as you can see. So we will first start by adding a, let's get crazy, we can add a 4 kilogram mass to our spring here. And then what I also want you to notice is how the potential energy gravitationally and within the spring changes, and how that potential energy is converted to kinetic energy. And then I'd also like for you to record in your notes the differences that you observe as potential energy changes, what happens to kinetic energy, and vice versa. So let's start here with the 4 kilogram mass. We will watch it all the way down and then all the way back up. If you notice, we've got, here's our equilibrium point right here where the spring started from and comes back to each time. And then as it drops down, you notice as it goes down that potential gravitational energy increases as that spring potential also increases. So then also notice how as potential gravitational, potential spring, how they move around, how that kinetic energy is adjusted. So then we can also, we'll hit start here, and then we can see how that looks on a graph. So if you notice, we get these nice sine waves as the spring moves up and down, and it gives us a really clean idea of how our graph should look when we're ignoring friction in these scenarios.